Hi everyone, my name is Neha, and today we're starting a brand new topic called quadratic equations. In this video, we'll be covering what a quadratic equation is and what are the three methods to finding the roots of a quadratic equation. Let's get started. First of all, what is a quadratic equation? A quadratic equation is an equation that takes the form of ax squared plus bx plus c is equal to 0, where a is not equal to 0 and the highest power of this equation is 2. Before we move on to our three methods of finding the roots of a quadratic equation, we need to understand the definition of roots. Roots are like values you can substitute for x in a quadratic equation, and when you do all the calculations, the whole quadratic equation should sum up to 0. Moving on to our three methods. Our three methods of finding the roots of a quadratic equation are the method of factorization, the quadratic formula method, and the method of square completion. Our first method is the method of factorization. Our equation is 1 minus 5x minus 14x squared is equal to 0. But there's something we have to do before we start our method of factorization. Well, if you go back to our quadratic equation form that we discussed, we know that our quadratic equation form is ax squared plus bx plus c is equal to 0. The 0 and 0 match in both of these quadratic equations, but the ax squared part, which is basically 14x squared, is at the back of the equation, and the c part, which is basically 1, is at the front of the equation. We need to flip around this equation. So when we flip around this equation, we get minus 14x squared minus 5x plus 1 is equal to 0. Now, the method of factorization says that we have to split this middle term, which is minus 5x in this equation, into two factors. So, to do that, we take two variables, suppose a and b, and say that the sum of a and b is equal to minus 5, and the product of a and b is equal to minus 14. Now, can you think of two factors in which the sum of these two factors is minus 5 and the product is minus 14? Pause the video and give it a think. Well, the two factors are minus 7 and 2. Minus 7 times 2 is minus 14, and minus 7 and 2 plus 2 is equal to minus 5. Now, for any general equation, the sum of these two factors will be equal to b in b, and the product of these two factors is equal to c times a if a is not equal to 1 and is equal to c if a is equal to 1. Now, I'm just going to take these two factors that I have, which is a is equal to minus 7 and b is equal to minus 2, and I'm going to substitute it for minus 5x. So I get minus 14x squared minus 7x plus 2x plus 1 is equal to 0. Now what I'm going to do is I'm going to make pairs of these factors. So I'm going to group minus 14x squared and minus 7x, and I'm going to group 2x plus 1 together. So we can't reduce 2x plus 1 but we can reduce minus 14x squared minus 7x. When I reduce this, I get 2x plus 1 times 2x plus 1 is equal to 0. Now, this is your checking point. You want to make sure that these two factors in the brackets are the exact same. If they are not the exact same, go back and double check your steps. After this, we know that if 2x plus 1 times 2x plus 1 is equal to 0, then one of these factors must be equal to 0. So, either case that we take, we get 2x plus 1 is equal to 0. And when we solve this like an equation, we get x is equal to, by isolating the variable and taking all the variable, non-variable terms to the other side of the equation, we get x is equal to minus 1 by 2. But wait, this is not the only factor. There's one more factor. Because addition is commutative, that means minus 5x is not only equal to minus 7x plus 2x, let's make this positive, plus 2x, it's also equal to 2x minus 7x. So, I'm going to rewrite the middle term like this. Minus 14x squared plus 2x minus 7x plus 1 is equal to 0. I'm now going to repeat the steps that we did earlier. When I group these two together, I know that I can't reduce minus 7x plus 1 any further, but I can reduce minus 14x squared plus 2x into minus 7x plus 1 times minus 7x plus 1 is equal to 0. Now, we know that one of these factors has to equal 0. But so in either case, minus 7x plus 1 is equal to 0. And when I solve this, I get x is equal to minus 1 by minus 7. So these are our two roots. So you can cut off the minus and you get 1 by 7. So these are your two roots. And this is one example of the method of factorization. Now, moving on to the quadratic formula method. Our equation that we're going to take as an example over here is 3x squared plus 32x plus 12 is equal to 0. Now, to solve this equation, we're going to apply the quadratic formula, which is b squared minus b plus or minus root b squared minus 4 into a into c all over 2a. Now, all I'm going to do is I'm going to substitute the values from this quadratic equation into the quadratic formula. So, when I substitute it, I get minus b is just minus 32, plus or minus root b squared, which is basically minus 32 squared, minus 4 into a, which is 3, into c, which is 12, all over 2 into a, which is 3. Now, minus 32 is the opposite of minus 32, which is 32, plus or minus root minus 32 times minus 32 is equal to 1024 minus 4 times 3 is 12. 12 times 12 is 144 all over 2 times 3, which is 6. Now, what I get after this is root 24. So I get 32 plus or minus 1024 minus 144 is equal to root 880 all over 6. Now I can simplify root 880 into root 2 times 2 times 2 times 2 times 5 times 11. So 32 plus or minus root 2 times 2 times 2 times 2 times 5 times 11 all over 6. Now I can take 2 out and I can take this 2 out because 2 times 2 is 4 and root 4 is 2. And again 2 times 2 is 4 and root 4 is 2. So I get outside the root, I get 32 plus or minus, I get 2 times 2 is 4 root 55. 5 times 11 is 55 because that's the only thing left in the bracket all over 6. Now I can take a common factor from 4 and 6, which is 2. 2 times 2 is 4 and 2 times 3 is 6. So our first answer is the roots of this quadratic equation is 32, since it says plus or minus over here, plus root, so 2 root 55 divided by 3, and also the root is 32 minus 2 root 55 div all over 3. So these are our roots, and this is one example of the quadratic formula method. Our last method we have is the method of square completion. As an example, our equation that we have is 9x squared minus 3x minus 2 is equal to 0. Well, how do we solve this equation? Well, to solve this, our goal is to turn the left side of this quadratic equation into a whole squared form. So our first step is to take we're going to divide the whole equation by a. Why we're doing this is the reason we're doing this is so that we can isolate x squared, so we can solve this quadratic equation. When I divide all over by 9, I get x squared minus 3 by 9, which is basically equal to 1 over 3. So I get 3x by 9, which is equal to 1/3 x, minus 2 over 9, which is equal to 0. Now, what I'm going to do is I am going to take whatever's not useful to x, whatever's unnecessary, extra, I'm going to take it to the right hand side of the equation. Since minus 2 ninths is not related to x because it doesn't have any variables in it, it's a non-variable term, I'm going to take it to the right hand side of this equation. So I get x squared minus 1/3 x is equal to 2 ninths. Now that that's done, what I'm going to do is I'm going to take this second term over here. I have this bx over here minus